The last topic we're going to look at as part of our fourth unit is called allocating kernel memory. Now kernel memory is the memory which is allocated by the OS for its own internal operations, right? So kernel, you will remember, is a part of the OS. It is the core of the OS. Now the OS is what is guiding everyone. It is what is telling everyone in the operating system, everyone in the computer what to do, how to do their job and all. So for that, to manage its own internal operations, the OS needs some memory, right? So that is how it will store its own instructions, its own data. So I need to ask this CPU to do a round robin. That note to self from an OS to the OS itself is stored in the kernel, such information. So that for that you need some memory. So that memory which the OS allocates to itself for its own personal note is called kernel memory. We will not go into this in too much detail. We will just touch upon it very lightly. This memory can be allocated in two ways: A, buddy system, B, slab. Buddy system means you are basically allocating contiguous blocks. So your entire memory is this, you're dividing it into two contiguous blocks, that further into smaller blocks, and you will take contiguous blocks. That is what buddy system is about. In slab allocation, you have specific kernel objects, what we call the kernel objects. So kernel object is one specific entity corresponding to one function by the kernel. So kernel has some instructions corresponding to scheduling, that is one object. Something corresponding to memory management, that is another object, and so on and so forth. So each of these goes into a different part of the cache memory, and from the cache memory it is mapped onto specific slabs of the main memory. Slab is just a segment. So the idea is, in buddy system the memory location is contiguous. In slab allocation it need not necessarily be contiguous. So to keep track, as the intermediary we have a cache. So that's that, kernel memory.